Hello, so today we are going to do this problem called minimum number of refueling stops, which is part of Leetcode daily challenge for August. So the problem says we have a car that travels from a certain starting point to a destination, and the destination is target miles away. Yeah, you don't need really to worry about the destination, the direction. Just imagine you are here. We are going to some destination somewhere here, and along the lines we have stations that we can stop at and refuel. So that's pretty much there. Yeah, so we have gas stations along the way, and gas stations are represented in an array where each value is the position of the station and how many fuels can we get from that station. Yeah, so that's pretty much it. So the position is relative to the starting point. So how far away are we from the starting point? And basically we don't need to worry about the car tank being limited. We can consider it infinite, so we can put as many fuel as we can or as we want. But initially it has this value, start fuel liters in it, and for each mile we travel we use 1 liter, so that simplifies it, right? And when we reach the destination, when we reach a gas station, we can stop and refuel. Yeah, pretty much. So what we said earlier, transferring all the values, all of this to the car for that station. And the goal of the problem is to return the minimum number of stops where we refuel, and in order to be able to reach our destination. And if we can't reach it, we return -1. So basically, we start from some position, we want to go to a destination, and along the way we have stations. We can stop at whichever stations we want to get the fuel we need so that we can reach the destination, right? And when we reach the destination, we can have either some fuel left or 0, as long as the fuel gets us to the destination, right? And if we take a look at, so what we want to return is the minimum number of refueling stops. So we want to minimize the number of stations we stop at. So that's what the problem is, because that's to do here. And let's take an example here. So we start at target 1. And we want to go to, our starting position is 0, and we want to go to 1. And we start with 1, so we don't need to take anything. And anyway, the stations are empty, so we can return 0. We don't need to stop at any station. Our destination has value, is 100 miles away. We start with 1, and we have these stations, right? So you can see here, well, we can't reach the first station even, right? Because we have only one enough fuel for 1 mile, right? And so we return -1. If you take a look at this example here, this one is a little bit more interesting. So target is 100 miles away. We start with 10, right? So we drive to the first position, 10, right? And so we using this amount of fuel, right? And we refuel with 16 liters, so now we have 16. And so we drive from there to 20, so that will use 10 fuel, right? 10 liters. And so we from 16, so we are left with 14, right? So we drive again to 30. Notice here what I did is subtract 20 from 10, because 20 is relative to the starting position. So that would be important later. Yeah, so we travel to position, after that we travel to 30, right? So we have another 10, and we end up with 20 left, okay? But here, we have to refuel, right? Because we have 30 to go, and we have only 20, so we have to refuel. So refuel here, we have 15, and now we can reach this station and then reach our destination of 1, because we have because we have 15 liters, right? And so if we count overall, we made two stops, right? So that's roughly, I hope that was clear, but just go through it yourself, and it should be clear. Now let's see how we can solve it. Okay, so let's see how we can solve it. So the problem is that we start from this start position, right? And then we want to go to target. So this is destination. It's target miles away, right? So this is, all of this is like target miles away. And the thing is that we have these station stubs. So we have S1, let's say, and then later we may have S2, and then we have maybe a couple of ones like SI until we get to our destination. Okay, so that's what we have here, and each of them has like a certain amount of fuel, right? And here we have a start fuel, right? Now intuitively what we want to do here basically is minimize the we want to minimize number of stops. So intuitively, to do this, what we need to do is first only stop when necessary, right? So only stop when we don't have any fuel to make it to our, either to the next station or to our destination, right? The second thing that is intuitive as well is only pick from the, if you have a choice between two stations, only pick from the one with the largest amount of fuel, right? So pick from station with largest amount of fuel, right? Let's take an example here. Let's say this one has maybe let's say has 60 fuel and this one has 20, right? And let's say we have, this one is maybe like 10 miles away and this one is 10 miles away, okay? And let's say here we start with fuel equal to 20. So we can make it until S2, but we can't make it past that. So we have the choice of refueling at S1 or S2. According to this, we shouldn't stop to the first one. We shouldn't stop at both positions because we want to stop only when necessary, and it's necessary only to stop at one of these to be able to continue, right? The second thing is to pick from the station with the largest fuel, because if we pick from this one, we have a higher chance of continuing without making more stops, right? Okay, for example, let's say this here was at 60 miles, right? Then if that's the case, okay, so if let's say this was 60 here, then it's easier, it's more optimal to pick here than to pick here, because then otherwise, let's say maybe this one is 30 miles away, and then we have so yeah, let me actually make this be 20 just to make this realistic, because otherwise they would be on the same position. So let's say this one was 30 and maybe we have 50, right, fuel 30 miles away. So if we take from this one, we have to refuel here. So now we refueled from 2 instead of refueling just from 1, right? So the optimal solution for us is to pick from the largest fuel if we have the choice, and here we have the choice, so we pick from this one. Okay, so for the first one, it's easy to implement that. So and by the way, this is like just doing it greedily, right? Because we are greedily taking only one necessary and picking from largest, because that will allow us to get the minimum number of stops, right? And so for one, it's easy to decide, it's easy to do that because we can pick only when our current fuel is less than 0, right? So we come at a station, we see if we can make it to it with our current fuel. If we can't, then we go back and see if we can refuel. That's the important piece here. So for one, let's say what we do in the real life, like you can't just go and have no fuel to get there, because then you would have to come back and you can't come back, right? But in this simulation implementation, we can, right? We have the data for all the stations, so we can. So what we'll do is actually just, so what we can do is basically in this case, so we arrive at 10, we have only 20. So we arrive at 10 and then we arrive at 20 miles away. And then we don't refuel yet. We just store that we have seen stations that have 20, 10, and 20. And so when we arrive at this station here with 30, we identify that our current fuel, right, it was 0 here. When we arrive here, we used all the 20, so we have 0. So when we arrive here, we find that, well, now if we subtract that, we have minus 30, so it's less than 0. And so we have to have had refueled from one of these two. So this is actually 60 and 20. So we have to refuel from one of these two, right? So the main idea here is keep iterating on stations, until we get current fuel smaller than 0. Then look back at stations we've seen and pick one of them, right? Basically, we don't refuel. Let's say we arrive at while iterating, we get to S1, right? So we do 20 minus 10, we have still 10 left, right? And then we arrive at S2, 20 minus 10, so that we need 10 miles, and so we use that 10 miles. So now we have 0 left, but we don't refuel it. We just note in some data structure that we've seen 2 stations, one with fuel 60 and one with fuel 20. And then when we arrive at this one, well, now if we subtract 30 minus 20, that's minus 10, right? So now we have minus 10. Now we see that we are less than 0. So we need to refuel from one of these two that we've seen before, and then we refuel. So that's how we can implement the first one, which is only stop when necessary. So only when our current fuel is less than 0, we check our data structure that has the stations, and then we can pick from it. Now, the decision point here is what data structure to use to store fuel from previous stations. Okay, that's where we can. The other constraint we have is that we want to pick from the largest station here. So in this case, when we arrive here and we have 16 and 20, it's optimal to pick the largest one, 60. So we want, and let's say maybe we've seen 5 stations, right? Maybe one with 30, one with 10, and one with 5, right? So we want to be able to pick the largest without traversing the entire list, because the stations are not guaranteed to be sorted with refuel amount, right? And so we want a way to pick the largest element easily, and that's a priority queue. So to be able, for 2, we can just use a heap or a priority queue to store fuel for previous stations. Okay? And yeah, that's pretty much the bulk of the idea of what we want to do, of what we want to implement. Now, one thing though is, what if, let's say we have start here, right? And then we have S1, let's say that has maybe, let's say 10, it's 10 miles away and has, let's say 10, and we start here with 10, or we start with 20. And then we have S2 that has maybe, let's say it's 10 miles away and has 50. And let's say we have another one, S3, that has 10, and then it's, so this has to be 20, this is 30, let's say, and has 40. And let's say here we have initially 30, right? And now here we have S4, that is, and then we have destination somewhere here. And then here, let's say maybe it's 40, and we have 60, right? So if we see this here, so we will add 10, 20, 30. Actually, let's make this a little bit more interesting and make this at 80, right? So what you see here is that when we get to this station here, 80 minus 30, that means we need 15 miles. So we need 15 of fuel. So, but we are at 0, so that would mean minus 50, right? And you can see here we actually need to pick from the 2 largest stations, so 20 plus 30. So it's not always picking just the largest single station, it's stations, right? So that's basically means that if we reach fuel, current fuel is smaller than 0, we need to keep popping until it's no longer small, it's no longer negative. So we need to keep popping and adding to the current fuel. And so adding basically periodic queue.pop, right? And here, each time we pick and pop from the queue, that's a stop that we have taken. So that's how we calculate the min stop, okay? Yeah, so that's pretty much roughly the idea. So we go through the stations, we keep decrementing the current fuel using the distance we need to traverse to that station, and check if the current fuel is less than 0. Then we do then we check how many we can pop from the station. Now, if we pop everything from the current priority queue and we still have current fuel smaller than 0, let's say, for example, maybe, so this is overall how many, 50, 60, let's say here we have it instead 100 miles. So, which means we need 70, minus 70. But this gets us only 60, so it's not possible actually. So we need to return -1. So if after popping from all the stations we've seen, we still have this smaller than 0, that means we need to return that. It's not possible, we need to return -1. Okay? And while iterating through stations, just remember we need to add to our priority queue. We need to add these values to our priority queue. Yeah, so this is pretty much a sketch of the different parts of the idea. Now we can just implement them in a more structured way and make sure it passes test cases. Okay, so let's implement this. So what we need to do is we want to go through stations, right? So stations have position and fuel. And we need our priority queue that will store the stations we've seen so far in it. And then we need our current fuel, which starts out as equal to start fuel. And then we need to do one thing, because we want to reach target, right? And so what we want is we want to add it, to simplify our implementation, we want to add it to our stations, but it has 0 fuel, so let's just put it like that. So why are we doing this? Because in this loop here, we will return -1 if we are not able to reach a station. But we also want to return -1 if we are not able to reach the target. That's our end goal anyway, right? So that's why we add it here. Okay, so now we need to decrement each time we reach a station. We need to decrement how many miles it took us to get there. And since stations are like, so we have, what we said in the overview is we have start right here. And then we reach station 1 here, right? And we get the position here is, let's say, and then we reach station 2. Maybe station 2, let's say, is, actually, yeah, it's clever to do this like this. So let's say this one is 10 miles away, and this one is 20 miles away. But we reached already S1, right? When we, in the iteration for S2, we reached already S1. So the distance is actually 20 minus 1, because we already traversed this one to get to S1 in the first iteration. And so we only need this amount here. And so that's why we do, this amount here is just 20, which is the current position, minus whatever was the previous value. And so we need to start the previous value. Initially, previous value is 0 because start is at position 0. But each time we want to set previous to be the position of this station, so that the next iteration is the position of the previous station. And the other thing we want to do is, when we get to each station, we want to record how, in the priority queue, we want to record the fuel in it, so that if we are not able to reach another station or target down the line, we can go back and look at how many we have, right? So that's why here we are going to add minus fuel. Now, why minus? This is just because this is Python, it's a min queue, and so we want to do minus so that when we extract, we get the biggest value, and we can just put minus in front of it to get the original value, right? And now what we said in the overview, which is while we have the current fuel smaller than 0, which means we have to refuel at one of the previous station to get to this station, right? But to be able to refuel, we need the priority queue to contain some value, right? And so here, what we do is we extract from the priority queue, heap pop, we extract the highest value, and we need to put -1 in front of it because we added it here. So this is largest fuel, we can just call it fuel, right? And we need to add that to our current fuel, right? And if this is enough, this would be bigger or equal to 0, and then we can exit, right? But this means here that we stop it at this station, right? So we need to increment our number of stops that we return at the end, and so we need to initialize our stops variable, and that's what we return at the end here. So we return stops, right? And here, if we try to refuel in all the stations that we've seen so far, but we still can't get to the station, which means that, or this target position, then that means we need to return -1 because it's not possible. And that basically is when the current fuel is smaller than 0. Yeah, so that's pretty much all there is to it. Yeah, so greedy, and we can use the priority queue. So let's run this. Let's use more examples. And we can submit. Oh. Yeah, so we have an issue here because we overrode this fuel value. So let's call this largest, or next largest, right? And add that here. Or we can even just like add it like this. Yeah, that should be easier. And if we run this on the example that didn't pass, and submit, and that passes test cases. Yeah, so that's pretty much it for this problem. Yeah, please like and subscribe, and thanks for watching. See you on the next one. Bye.